All right, this is Mr. Wyrick. I'm kind of going over some of the stuff for Thursday, January 30th. I will be out. So this is the assignment from yesterday. Find the missing side, round to the nearest tenth. I'm just going to kind of set this up for you. So we've got our angle here, it's 46. We don't have the opposite side, but we do have the hypotenuse. So this is going to be cosine, because we have the adjacent and the hypotenuse. Cosine of 46 is equal to 19 over the hypotenuse. Okay? So the x, the hypotenuse, is what we don't have. All we're going to do is swap these. This is going to be x is equal to 19 over the cosine of 46. When we come to this one, same kind of thing. We don't have the opposite. It's the adjacent. This is going to be the cosine of 33, and it's going to be equal to x, the adjacent side, over 11, the hypotenuse. In this case, we just multiply both sides by 11. So if you type in 11 times the cosine of 33, that's going to give us our x value. Most of the rest of these are going to be the same thing. Just pay attention to whether you have the opposite side, like here, that'll be sine. Opposite side here is sine. And on these two, we don't have the hypotenuse. We are going to use tangent. Down at the bottom, same kind of thing here. We've got the hypotenuse. This one's got the opposite, so we'll do sine, because sine is opposite over hypotenuse. On this one, we have the opposite. We have the hypotenuse. That's, again, going to be sine. On the back side of the page, find the measure of the indicated angle. This is where we're going to do, like, sine, cosine, and tangent again, but we're going to use theta. So on this one, the sine of theta, we have our hypotenuse, we have our opposite side, so we're going to use sine. The sine of theta is equal to 9 over 14. When you go to solve this, theta, your missing angle, is going to be equal to the inverse sine. Okay, you push the second button, then the sine button, that'll give you the inverse sine of 9 over 14. That'll get you your answer for the angle on that one. And remember, if you hit the second button, and then you hit the decimal button, and then on this one you hit 0, that'll round it automatically on your calculator to 0 decimal places, so it'll be the nearest degree, and you'll already be set on that one. Then the mixed review is what you'll be doing today. So it starts off with the geometric mean between the two. Remember, this is like x over 8 is equal to 12 over x. You'll cross multiply. 8 times 12 is going to be 96, and that's going to be equal to x squared. You'll take the square root of both of those to get x. Same thing here with 3 and 15. It'll be the square root of 45. It does say reduce the radicals, but I'm going to kind of ignore that for now. You can have the decimal equivalent on that. It doesn't bother me. Same thing with this one on finding it. You have to see what has it in common. So if I go with the y, that's this small triangle and then the largest triangle. So on this one, it's 8 for the short side is to y on the hypotenuse here on that small triangle is equal to, the y is the short side on the largest triangle, and 8 plus 23 makes 31. I would cross multiply those, and then I'm going to take square roots. Down here, Pythagorean Theorem, just remember where you have to add and where you have to subtract. I have the legs here, that's a and b, so I'm going to add those two together and then take the square root. I have a hypotenuse and a leg here. It's 136 squared minus 120 squared, and then take the square root of that to get that answer. On the back side, the a squared, the b squared, the c squared, find out how it compares. So 3 squared is 9, 7 squared is 49, and 8 squared is 64. Well, 9 plus 49 is going to be 58. That's smaller than 64. So this one, since the c side is bigger, is obtuse. Okay, you may need to look at the old paper to see which is acute, which is obtuse, and which is right. Down here, the 45, 45, 90, and 30, 60, 90 triangles. If both of the sides are the same on the 45, 45, 90, the hypotenuse is the number times the square root of 2. On the 30, 60, 90, we have the short side. The hypotenuse is double that, and the long side is the short side times the square root of 3. If you have questions over this stuff, if you weren't sure what was going on, just make sure to hang on to it until I come back, and we'll go over them in class on Friday.